So one of the first steps in the manufacturing process is making sure we have all the right parts. We get the chassis from the machine shop, we do quality inspection and make sure that all the measurements and tolerances are within specification. And then the first step is to install the MDM connectors, and great care has to be taken not to damage any of the pins in manufacturing, and so they get taped up. And then we seal off the ends of the chassis where the connector wiring comes in with RTV. We receive the nearly fully assembled circuit boards with all the machine place surface mount components already installed by our manufacturer, and then we solder the wiring harness onto the circuit board. The next step is to program the boards with the appropriate firmware and to run the first set of functional tests on the bare boards. Once that completes, then the boards and the chassis get thermal cycled to 175°C to make sure everything functions as it should at high temperature. And then once they pass that, they go back into the shop for a few additional manufacturing steps where the board gets finally installed into the chassis. The board comes then to this second thermal test where it gets once again cycled to 175°C overnight to verify all operation of the board and the system is as it should be. Once all that testing is complete, the next step in the production process is to go to HAUS, which stands for Highly Accelerated Stress Screening. One of the most important parts of the manufacturing process is the HAUS test. So here we're mounting the Micropulse tools in the HAUS chamber, and we're going to be taking the tools to very cold temperatures and to very hot temperatures, all while applying vibration. And you might not think that initially the cold temperatures are realistic for a downhole environment, but by taking them from the cold to hot temperatures, it mechanically stresses the electronics and identifies any potential weak points in the system. So the first part of the HAUS test is the cold step, and so this chamber blows liquid nitrogen into the chamber to cool the tools down very rapidly, and then once the cold step is complete, it uses very high power heaters to rapidly heat the tools up to 175°C, all while shaking the tools under 35 G's RMS vibration. So the air temperature is at 0°C or just slightly below, so that's freezing, and the vibration is at 35 G's. The next step of the process is the sensor calibration, where the accelerometers and magnetometers on the tool get calibrated with temperature. So the tool is taken to various temperature steps and readings are taken from all the sensors. And with all that data combined, we can generate calibration curves for all the sensors to correct their measurements across the full temperature range of the tool. So once the calibration is complete, the tools then cool back down to room temperature, and then they go through what's called thermal validation, where we recheck the high temperature and the room temperature calibration performance to ensure that the calibration was within specification. As part of validation, the tools are roll tested to ensure that they're within our internal quality control specifications on directional sensor accuracy. And we also use third-party CalCheck software from Superior QC to ensure their tools are within and exceeding industry expectations. Once the calibration and validation steps are complete, the tools move on to the final production step, which is the pre-shipping test. And so everything on the tools gets retested, and then the tools are ready to get packaged up for shipping. Paperwork is loaded into the shipping box, and the tool itself is ready to go.